yes, my name's Adele, and I'm a software engineer at Trifork Amsterdam. And I want to start off by thanking you for choosing this session. People standing is a little bit of a speaker's dream, so thank you. I actually do have some stiff competition with this spot, with Roy Osherov speaking in another room. So I really thank you for coming here, and I do hope that you aren't disappointed. And of course, what I really mean by that is that you won't be disappointed. I mean, hooray who? So for those of you who aren't aware of Trifork, we are a project-based consultancy founded in Denmark in the 1990s, and we now have offices throughout Europe and even a couple beyond that. The keen observers among you might recognize the Trifork logo from the GOTO website. So yes, organizing GOTO is also part of what we do. Now, each location of Trifork has a slightly different focus, but what we all have in common is a passion for building great software and, I suppose, organising great conferences. So the Amsterdam office that I work in has a very strong focus on Java and Spring, and I use those along with Kotlin to build and maintain applications for the educational sector. And yes, like every tech company in the Netherlands right now, we would love some new colleagues. But so I also think it's worth giving a quick overview of the format of today's talk. It's probably a little bit different to the other talks that you will see today, and also in the other days at this conference. What I'm going to be doing is exploring a case study in a storytelling format. Then we'll pull out some lessons that we can apply to software development. So there's a little bit of drama, and you will need a little bit of imagination. But before we get into that, I would like to share a little anecdote about myself, just to give a little bit of a background of how I got interested in this topic, and to give any late-comers the chance to get settled. Also, if anyone meant to see Roy's talk, just a moment for them to politely excuse themselves. So I took my first flight just before my 6th birthday, and I do remember it quite clearly. It was a 4-hour flight from Melbourne to Perth in Australia. So in case you were wondering, this is not a typical Dutch accent. This is an Australian accent with 5 years of Dutch influence. So anyway, back then, in the crazy time that we call the 90s, if you were a curious 6-year-old, it was not uncommon to get invited into the cockpit in mid-flight. I remember being in the cockpit and the pilot asked if I thought that it would be hotter or colder at 30,000 feet than on the ground. Now, my brother, he was 11 at the time, and he said, colder. I scoffed. What would he know? My 6-year-old logic told me that we were in the sky, closer to the sun, so obviously it was hotter. The pilot pointed to a metal panel and he asked me to touch it. It was ice cold. My brother just laughed. So thankfully, my understanding of physics has changed and improved since then, but my love of flying has not. So even as a fully grown adult, you will find me with my head pressed against the window, just looking around and taking it all in. I just find that there's something magical about being up there. And if you add in the curiosity of an engineer, then you end up being a little bit of an aviation geek. So, for example, I just got back from a vacation to Greece, actually not completely unscathed from the chaos that is European air travel right now. There were actually a few stressful hours where I thought I wouldn't make it here today. Anyway, I did make it back in time through some last-minute business class fares, which I'm still a bit angry I have to pay for, but never mind. But I managed to take this photo on the flight from the island to the mainland. So this is from an ATR 42, and for some reason, where I was seated in row 1, it was the only row with the seats facing backwards. So it gives me the perfect view of the propeller. Pretty cool, right? And my boyfriend in the aisle next to me got the perfect view of the back of my head. Okay, so it's case study time. Are you ready? Are you ready? Yes, great. So, it's 5:05 p.m. on a cold evening a few days after Christmas in 1978. The crew of United Airlines Flight 173 are preparing to land a fully laden DC-8 in Portland, Oregon. It's been an uneventful flight for the passengers from Denver, despite the usual Christmas chaos at the airport before departure. First Officer Rod Beebe, age 45, is the pilot flying. Although an experienced pilot, he is relatively new to the DC-8. This is a large, narrow-body aircraft with seating for about 180 passengers. It's a career milestone for him, which almost makes it worth being away from his young family so soon after Christmas. He's now down to an altitude of 10,000 feet, so he asks the captain and his friend, Melbourne McBroom, to lower the landing gear. McBroom obliges. Suddenly, a loud thump echoes through the aircraft. This is followed by a jarring vibration and a sudden pull of the nose of the plane to the right. Beebe and McBroom scan their instruments. The gear light is not illuminated. Now, unless the light is malfunctioning, that means that the gear is not fully extended. An error deploying the landing gear would, in fact, explain what their sensors had just told them. "What on earth was that?" yelps Second Officer Forrest Mendenhall, who goes by the nickname Frosty. Beebe and McBroom look at Frosty, then back at each other. They both know that landing without the main gear is an extremely risky maneuver that could easily result in disaster. It's time to put their training to use. Captain McBroom radios Portland Airport approach and tells them that Flight 173 will be staying at 5,000 feet and entering a holding pattern while they attempt to resolve the issue. They'll keep the speed steady at 170 knots. "We've got a gear problem. We'll let you know." Portland provides a heading for the hold. Over the next 25 minutes, the three men discuss and accomplish all relevant emergency and precautionary actions in an effort to reassure themselves that the gear is in fact down and locked. Frosty even enters the cabin for a visual confirmation of the wing indicators. They pop up when the gear pops down. It's dark by now, but Frosty can see them clearly. Frosty re-enters the cockpit to find Captain McBroom discussing the likelihood of an emergency landing with the head flight attendant, Joan Wheeler. An old-school gentleman, the captain doesn't want to frighten the passengers or hurry the girls, as he put it. He tells the ground that he and his crew will take their time and get everybody ready before attempting a landing at Portland Airport. The ground keeps them in a holding pattern. Joan returns to the cabin and, in unison with the rest of the cabin crew, calmly begins taking steps to maximize the chances of survival in an emergency landing. She knows the plane is in a safe holding pattern, so she can take her time and do everything by the book. In her 14 years as a United flight attendant, she has never had to prepare for such a landing. But she makes it look effortless. She patiently reminds people of the brace position. She asks able-bodied men to sit in front of the emergency exits. She instructs mothers on how to best wrap their babies. She reassures children. Now, please do excuse me here while I perpetuate gender roles, but it was 1978. This is what happened. In the cockpit, the three men continue exhausting all avenues to ensure that the gear is in fact down and locked. Yet in between directions from the captain, Beebe and Frosty are passing each other increasingly worried looks. It's now 5:55 p.m. and Flight 173 has been in a holding pattern at low altitude for the gear down for 50 minutes. That's 50 minutes. Beebe asks Frosty how much fuel is remaining. Frosty stutters, 4,000 pounds, one in each tank. Beebe does some quick math. At the current burn rate, they might have enough for 18 minutes. At that moment, the approach tower provides the next heading. It's towards the airport. Beebe breathes a quick sigh of relief. Surely we're going in now. The captain still focused on the gear, asks Frosty to do yet another sweep of the cabin to check how things are going. The captain's number one priority is a safe emergency landing with a fully prepared cabin. No surprises. Frosty obliges, but he would much prefer to be assisting the flight deck as they make the final preparations for landing, which must be only a couple of minutes away. Frosty returns to the cockpit at 6:01 and tells the captain that the cabin is 2 or 3 minutes away from being ready. But at that moment, he feels the plane bank to the left, away from the airport. Shit, he thinks to himself, another hold. But before he can say anything, the captain asks about the welfare of the passengers. Hey, Frosty, how are they doing back there? Yeah, they're pretty calm and cool. Some are more anxious than others. I did my best to reassure them while I was back there. The captain replies, okay, well, 2 minutes before landing, about 4 miles out, pick up the mic and tell them to assume the brace position. Frosty confirms and then takes the opportunity to gently remind the captain of the fuel situation. You know, we got 3,000 pounds of fuel and that's it. That equates to about 13 minutes. Without flinching, the captain advises Frosty on what to do if the gear collapses on landing. 4 more minutes pass. The captain sucks Frosty and BB into a further conversation about the emergency landing and whether the gear is in fact down or locked. Joan enters the cockpit and announces, well, I think we're ready. The captain acknowledges and advises that they will be landing in about 5 minutes. While the captain wraps up the final details with Joan, BB addresses Frosty. Hey, buddy, I think you just lost number 4 engine. Joan thanks the captain and leaves the cockpit. Buddy, BB continues, I think you just lost an engine. This time, the captain is listening, and he seems surprised. Why'd we lose the engine? BB utters just one word, the concern on his face, as clear as day. Fuel. It's now 6:07, and finally the captain asks for a heading back towards the airport. The plane starts banking to the left. Engine number 3 stops. The official term is a flame-out. Now the fuel situation has the captain's attention. He asks Frosty to open the crossfeeds. This allows whatever fuel is left to power the two. Whatever fuel is left, it allows it to power the 2 remaining engines. The captain insists that the tank that's feeding number 3 engine still has 1,000 pounds of fuel. Tensions heighten as the captain keeps barking at Frosty about the crossfeeds and the extra 1,000 pounds of fuel that doesn't exist. It's 6:09. The captain asks Portland approach for a final heading towards the airport. He does not convey the seriousness of the situation. The airport still expects a landing where the gear might collapse. Emergency services are standing by. He follows up by asking how far away they are from the runway. The response is 18 nautical miles. That's 6.5 minutes. They have 5 minutes of fuel left, tops. Sure enough, 4 minutes later at 6:13, engine 1 and 2 begin to splutter. Flame out is inevitable. Finally, the captain declares a mayday. Within seconds, the plane clips a tree and then another before ploughing into some power distribution cables. The plane slows as the wires stretch before crashing into 2 unoccupied homes, and coming to rest in a field. Because there's no fuel, there is no fire. Most of the 181 passengers on board, including 1 prisoner come fugitive, exit the plane physically unharmed. The prisoner, believe it or not, actually helped the passengers to flee the aircraft before he fled the scene. The captain and BB are among the survivors, injured but alive. Frosty and Joan, however, along with 8 others, are dead. The next morning, the newspaper hits the stands. Without yet knowing what has happened in the cockpit, the media labels Captain McBroom a hero, citing the miraculous landing without injuries or deaths of people on the ground. Survivors praise the flight attendants for their preparedness and for the orderly evacuation. It could have been a lot worse. But why did it happen in the first place? So, United Airlines Flight 173 is arguably the most important crash in aviation history. So if you ever took a flight after 1985, then I can guarantee you that your safety has been impacted by this flight. And in the final report, the investigators list a probable cause for this crash as well as a contributing factor. So I will read this because this is from the report. The cause was the captain's failure to properly monitor the aircraft's fuel state and to respond to both the low fuel state and the crew members' advisories regarding the fuel state. The factor contributing to the incident was the failure of BB and Frosty to either fully comprehend the criticality of the fuel state or to successfully communicate their concern to the captain. And the most alarming part of these findings was that they were not isolated. They were only the latest in a string of air crashes with similar causes. In the 1960s and 70s, the number of flights were growing dramatically, as were the number of crashes. So, for example, the most famous crash before Flight 173 was probably the Tenerife airport disaster in 1977. In this crash, two fully laden 747s collided on the runway, killing 583 passengers and crew. And similar to the flight of 173, the probable cause of this crash was the breakdown in communication. Only this time, it was both inside and outside of the two cockpits. Air traffic control also played a role. So in this broader context, the recommendations of Flight 173 were timely. NASA had already identified the issue of human error in the cockpit and were working on a solution called Crew Resource Management, or CRM. Now, I know that acronym might make you shudder a bit if you've ever worked on a customer relationship management system, but for today, Crew Resource Management. And in the investigation report of Flight 173, airlines were told to give this training to their pilots. Specifically, the crew resource management training should have two themes. So the first theme would be participative management for captains. In other words, providing a non-threatening environment that actively encourages collaboration. Second part is assertiveness training for other cockpit crew members. So how to get your point across effectively in a non-threatening manner. Now, in modern organizational terms, you could summarize it as ensuring psychological safety in the cockpit, which I actually find really interesting as this recommendation predates the term psychological safety by about 20 years. What's also really interesting is the emphasis on the assertiveness of the co-pilots. So it's not just the responsibility of the captain to provide a safe space, it's the other crew members also taking responsibility for how their message or advice is received. And in the decades that have followed the implementation of CRM, starting with United Airlines in 1981, obviously, indeed the culture of aviators has changed markedly. It's no longer a case of captain knows best. Every young pilot knows, no matter their experience level, that they not only have the right, they have the responsibility to speak up when something is not right. Now, you could argue that in software, the stakes aren't as high as human lives. But what if your failure to speak up sparks a chain of events that results in a data breach, a loss of faith with a major customer, or worse, a loss of faith in yourself? And of course, being prepared to speak up is different from knowing when to speak up. So how can you better tell if things are wrong or require further examination? That decisions are being made that ignore key evidence. What can we learn from Captain McBroom? He can teach us a lot about situational awareness. This is a fundamental concept for aviators. Put simply, situational awareness is knowing what's going on around you. In the case study, we saw that Captain McBroom was getting increasingly fixated on the landing gear issue, which left him unable to process the criticality of the fuel situation. He had lost his situational awareness. And if you are the proud owner of a human brain, it's very, very easy to lose your situational awareness. Actually, much easier than any one of us would ever like to admit. So, for example, have you ever dived into an issue so deep and got caught in the technical wonder that you kind of lost sight of what the problem that you're working on was in the first place? Or were you so focused getting to the conference on time that you failed to notice what a pretty nice day it is, especially for the Netherlands? So, as an engineer, if you fail to maintain the awareness of your situation, you end up with a perfectly engineered feature that nobody wants, or a hot fix for a small ordering issue that leaves your app unable to process payments. So, how can we maintain situational awareness in our roles as software professionals? This is a list that I've adopted from Crew Resource Management Training, or CRM training, interpreted in the software engineering context. So you can maintain situational awareness by considering the impact of stress and your workload on your performance. For example, how many tickets are assigned to you right now? How many meetings do you have planned? Which deadlines are real and which are arbitrary? Be honest with yourself and others on what you can accomplish. Having an appreciation of the automation and abstractions present. Are you aware of the abstractions that you interact with, even on a rudimentary level? Could you find the resources you need if the situation required it? Do you have a basic understanding of what happens when you run a job in Jenkins, for example? Like, what's it doing? What could go wrong? Paying attention to and meeting your physiological needs. So, did you sleep enough? Are you hydrated? Did you eat? Did you poop? Recognizing that you carry around preconceptions and bias wherever you go. So is your gut instinct actually just bias? Why does a certain course of action appeal to you over another? What evidence do you have to support your position? What evidence do you have against? And being aware of your limitations, for example, as they result to your abilities, experience, training, and communicating them when relevant. So what are your limitations or weak spots with respect to your role? How can you patch them? Who can help you? What knowledge could you share with others? A minute for the photos. Sorry, this is the last one. There you go. And crucially, maintaining situational awareness does not have to be a solo endeavor. So when we encourage an environment where everyone can speak up, share their knowledge, and challenge ideas, then you lift the situational awareness of your team, your crew. And this, as has been known in aviation for years already, leads to better decision making and better results. My name is Adele, and thank you so much for your time.